好，谢谢。
So our group has decided that we'll discuss the precipitation in Taipei City, which is the capital of Taiwan. Today, Peter and I will be reporting this. Next page. So here's a little table of contents. We have dissected this report into 10 sections. And we'll first start with a little information about Taiwan. So as we all know, Taiwan is a country in the West Pacific. So and it is an island which water resources shouldn't be a struggle for us. However, there's a mountain in the middle of the island. This creates a really sharp and steep slope, which just causes the water, the rainfall to just flow right into the ocean. So this becomes a problem, which makes water reservation utmost important for us. And since our agriculture and some semiconductor industry rely on it, it has become a really important issue for us to preserve the water. So we have thought about that, and we have thought about it, and we mainly will focus this report on the rainfall in Taipei, because it is the capital and it is the most populated. Next. So so for the data collection, we need like a really credible source. So we have decided that we will use the data provided by the Central Weather Bureau, because since they have the resource and the capability of conducting large scale and some long-term researches, they can provide us a very thorough data set. And for the training data, we have selected data from 2000 to 2016, which is like 80% of the 20-year data. And the testing set will be 2017 to last year, 2020. So this essentially creates a 80%, 20% ratio, which is ideal for training our AI, or ideal for machine learning. Next. So here we first will we'll download the CSV files from the Weather Inquiry system provided by the Weather Bureau. And the download file will look like this. And we'll later mention that we will use these data and create a sort of perform the linear regression to see what kind of weather parameters is relevant to the precipitation. Next. So after analyzing the data with Excel, mainly picking out which of the weather parameters are essential for our research, we will then use multiple linear regression to sort of determine and predict. Next.
And here I'm going to talk about the code we use. In Panda, we only use these two-row code. And first, we use read CSV to read in the data and create a data frame. And the second we use the second command we use is to select the column we want. And another library we use was scikit-learn, and we import linear regression from scikit-learn.linear model, and there are 5 rows code we will use in our project. And first, we create a model from linear regression. And next, we use model.fit to import the training set and training the model. And after finishing the training of model, we can see the coefficient of determination by model.score. And the input is independent variables and dependent variables. And we can use model.intercept to see the intercept of the model. And we can use model.coefficient to see the coefficient. And to use the Excel to analyze the data, first we come into the data tab, and at the right there is analysis, and we click in the button data analysis, and we click the regression, and we can do the linear regression. And why we use two ways to do linear regression is because in scikit-learn in Python, the p-value, we can only find the p-value of simple linear regression, but we cannot find the p-value of multiple linear regression. And it is more convenient to use Excel to find the p-value. So this is why we use Excel. And the approach we used to analyze our data is multiple linear regression. The first is the formula of multiple linear regression. Y equal to sigma beta x plus epsilon. Y is the dependent variable, and the sigma means that there are multiple independent variables, and beta is the coefficient, and epsilon is the error, which is the observed value minus predicted value. And in MLR, there are four assumptions is made. First is linearity, which means there should be a linear relationship between independent variable and dependent variable. And second is multicollinearity, which means there is an error in our PowerPoint. There should be no multicollinearity in MLR, which means that there should be no relationship between the independent variables. And third is the homoscedasticity, which means that, wait a minute, which means that there should be no clear pattern in the plot, in the residual plot. And the last is normality, which means that there should be normal distribution in the residual. And we use the list of sum of square of residual to find our coefficient. And residual is the epsilon in our formula. And to do the MLR to do the multiple linear regression, first we have to choose which parameters we are going to be independent variables, and there are 11 independent variables. There are 11 parameters we are going to select to be the independent variables, and we use Excel to do the simple linear regression between precipitation and those parameters, and we find out that most of the coefficients of determinations are very low, and we choose the coefficient of determination which is larger than 0.1 as our independent variables. And why we use 0.1 is because we think that there are many parameters affecting the precipitation. So we think 0.1 is reasonable. And the final result we choose is station pressure, sea pressure. There is a text error. This is a temperature dew point, and we choose station pressure, sea pressure, temperature dew point, and temperature. There is another typing error. This should be temperature, and we choose these 4 parameters as our independent variables. And after we choose the independent variables, we use Python to do the Python and Excel to do the MLR. And before seeing the result of MLR, we should check our residual plot. Why we should check the residual plot is because the formula of multiple linear regression is y equal beta x plus epsilon, and this epsilon is unpredictable. So if there is a clear pattern between the residual and independent variables, it means that your model has problem. And in our residual plot, there is no clear pattern, so we can say that the model has no problem. And
now we'll discuss the model accuracy. So normally the R-squared value, it should be above 0.5, but however, we only got 0.43, which means that maybe some of the parameters that we chose aren't as relevant as we thought it would be. But however, and the p-value over here, so a good p-value for the parameters would be below 0.05. That will represent that the parameters are statistically significant, which means that it can be used. We have 2 of the parameters, which is the sea pressure and the station pressure, that is above 0.05. However, after discussion, we have decided that the model is still accurate because you have a really low significance f, which the lower is the better. So the reason behind why these two parameters might exceed the value of 0.05 is because weather system is very complicated. There are actually more than the several parameters we mentioned that could affect the weather system. There could be like climate change or the El Nino phenomenon. Those could greatly affect our results. Next. So we have concluded that the several use for our model, it can mainly use to predict the precipitation, which can be very helpful in certain areas that is in need of large amount of water constantly, like the Taiwan Semiconductor Manufacturing Company and the Hsinchu Science Park. And the heavy water usage is because they obviously they manufacture semiconductors, and they roughly need about 156 tons of water a day, which takes up about 85% of the water usage in the Hsinchu Science Park. And the reason that we need these constant demand for water, they need a constant demand for water is because if one day the water supply just didn't meet their demand, the manufacturing of semiconductors could go terribly wrong, and it will greatly impact the global electronics market. So yeah, this is what we think our report can benefit in, and this has been our report, and thank you.
And allow me to do the complement. There is two reasons why R square is lower than 0.5 and our p-value is above 0.05. The first is, like Sean mentioned, the weather system is complicated, and the second is there is, from the residual plot we can see that there is extreme value. One of the point, the residual is larger than anyone. So the second reason is extreme value will affect our model. And this is our reference. Thank you.